Hi. One of the main applications of Laplace transform is to solve differential equations. And to solve differential equations, there are three major steps. The first step is to do Laplace transform to transform the differential equation from time domain to S domain. Okay, so you will use Laplace transform to transform from time domain to S domain. And then second step is to do algebraic manipulation on the S domain function such that we solve uh, for the for the function. Okay, for example, over here we want is. So we do algebraic manipulation to solve for the function for the is. And then the third step is to do inverse Laplace transform to transform this back from S domain back to time domain. So this is inverse Laplace transform to transform it back from S domain to time domain. So these are the three main steps. In the previous lesson, we have seen how to do Laplace transform of some basic functions. Okay, functions. We do the Laplace transform into S domain. Okay, and we used the Laplace transform table. Okay, we use the table. We refer to the table to do this transform. Okay, now if you look at the differential equations, the differential equation also contains the derivatives. Okay, so what is derivatives? Let's say we have a function ft. Okay, so ft is the basic function, and then the first order derivative. Okay, first order derivative is the df dt. Okay, and then the second order derivative is df d square f dt squared. So these are the derivatives of the function. For simplicity, we can just refer to this as f, this as f prime, and this as f prime prime, and so on. Third order, we can just put 3 primes. So now in this section, you will see how to find the Laplace transform of the derivatives, the f prime and f prime prime. Okay. The Laplace transform of the derivatives are given here. Um, if the Laplace transform of the basic function uh, is fs, then the Laplace transform of the first order derivatives is given by this, just s times this minus f0. Okay, and similarly the second order derivative is given by s squared times the fs. Fs is the Laplace transform of the f, and then minus s f0 minus f prime 0. Okay, now what are these f zeros and f prime zeros? These are initial conditions. Okay, it's written here, initial conditions. Basically, they are numbers or values that are known to us before we start solving the equation. It's given to us. These are just numbers like 1 or 5 or 3.5. A number that is known before we start solving the equation. They are the initial conditions. Okay, to better understand this, let's look at an example. Okay, let's say we have this function, this expression. Okay, let's say we have the expression 5i prime plus 10i. Okay, and also it's here. Okay, the initial condition is given as I naught equals to 1 ampere. So I'll write it here. Our initial condition I naught or I0 equals to 1 ampere. So this is given to us, and this is the expression, and we need to find the Laplace transform of this expression. Okay. So the steps are very straightforward. We just refer to this table over here, or um, this transform over here, and substitute. Okay. So whenever we see I prime, we replace this. Okay. But now instead of F, it is I. So we replace this capital F with capital I and small f with small I. So 5, and then our I prime becomes S F I S minus I naught. Okay, which is straight from here. Okay, and then plus 10, I becomes, okay, the I here becomes the capital IS. So IS. Okay. Now we can replace the initial condition. Initial condition is 1, so we can just replace it. This becomes 5 S IS minus 1 plus 10 IS. Okay. And here we have actually completed the transformation. We have transformed these derivatives into Laplace domain, S domain. Okay. But to make it more elegant, we will factor out the IS, because eventually we want to find the value of IS. Okay. So how to factor out IS? We will first expand it. Okay, we take this 5, we multiply into each terms. So this becomes 5 S IS minus 5 times -1 is -5 plus this one 10 IS. Okay, and then we factor the IS. We write the IS here and look for all the terms that contains IS. So we have 5S here. So 5S. This one doesn't contain, no need. This one is 10 plus 10. And then we write the terms without IS, which is this minus 5. Okay. So this is the final simplified expression for this expression. This expression, when we transform it into S domain, we get this expression. Okay, so that is what is shown in the next slide here. This is the time domain expression with initial conditions, and then we transform it. When we transform, first step, we just replace based on the table above, and then we replace the initial condition, and then this is the step 1. Step 2, we need to replace the initial condition, and then we expand it. We multiply the 5 inside, and then we factor the IS. Okay, so that's all for this section. Thank you.